In the last video, we discussed measurement systems used in physics. In this video, we will review some of the basic algebra which is needed for this course. In its simplest form, algebra is about number puzzles. If you had to explain to a child, you might say something like this. Here is a mystery box. It contains a number. If I add 3 to this number, I get 8. What number is inside this mystery box? And she would answer 5. Now, in algebra, rather than talking about mystery boxes, we use letters to stand for unknown values. But the purpose is still the same, finding those unknown values. The simplest type of algebraic puzzle is one where you have to calculate the value of a variable based on a series of operations done to numbers. The operations need to be done in a specific order, which we can remember with the acronym PEMDAS. First, solve everything inside the parentheses, innermost to outermost. Second, solve all exponents and roots. Third, solve all multiplications and divisions left to right. And finally, solve all additions and subtractions left to right. Let us see an example of using the order of operations to evaluate this variable. Now, the rules of order of operations say as follows. First, evaluate the parentheses. So 1 minus 7 is equal to negative 6. Everything else stays the same, but we have now evaluated the parentheses. Step 2, evaluate the exponents. 4 cubed is equal to 64. Step 3, do all of the divisions and all of the multiplications left to right. So 64 divided by 16 is 4, plus 8 times negative 6 is negative 48. And finally, do the additions and subtractions left to right. So 4 plus negative 48 gives us negative 44. And this is the value of x. Another type of algebraic puzzle occurs when a variable has a series of operations performed on it. You have to undo those operations in order to isolate the variable and reveal its value. The isolation process always occurs in reverse PEMDAS order. Here is an example of an equation where we need to isolate the x in order to solve for what its value is. We need to undo the operations that were done on it going in reverse PEMDAS order. The last thing that was done to this according to reverse PEMDAS would be the subtraction of the 3, because subtraction is the last thing that occurs in PEMDAS. So we have to do that first. We have to undo that first, rather, by adding 3 to both sides. That gives us 12 is equal to 4 times the square root of x plus 7 plus 4x. Now, the next thing that is required for the isolation is to undo any multiplications and divisions. That would be the second last step in PEMDAS. So, since the right side is multiplied by 4, I need to divide both sides by 4. That will give me 3 is equal to square root of x plus 7 plus 4x. Step 3 is to undo all exponents and roots. This expression over here is under a square root sign, so to undo the square root, I have to square both sides. That gives me 9 is equal to x plus 7 plus 4x. And finally, we resolve what is inside the parentheses and we do the process all over again. X and 4x are like terms, so they can be added together. That gives me 9 is equal to 5x plus 7. Now, there is a 7 added, so we need to resolve that by subtracting 7 from both sides, which gives us 2 is equal to 5x, and the last step is to divide both sides by 5. So we get that 0.4 is equal to x. And this is the solution to this equation.
Here is another type of algebraic equation. You'll notice it has two variables. The purpose of this equation is different. It doesn't provide a puzzle with two unknowns, because two unknowns requires two equations to be solved. Instead, it provides a relationship between the two variables. If you provide a value for x, you can use the equation to calculate a value for y. This type of equation is called a linear equation, and we can show several examples. They are called linear because when you graph them on the Cartesian plane, you get a straight line that extends infinitely far in both directions. In physics, many equations of motion are linear. All the equations that you see here have something significant in common. The x does not have an exponent. Sometimes it is multiplied by something, and sometimes it is added to something, but it never has an exponent. This is characteristic of linear equations. We can say a linear equation has this general form: y equals mx plus b. M is the number that gets multiplied by x, and b is the number that subsequently gets added to that product. Linear equations have several interesting qualities, but the most relevant one for us is this.
Here is a typical linear equation. Suppose we set x equals 2. What is y equal to? Well, we can plug x, this value of 2, into this linear equation, and we can solve for y. 4 times 2 is 8, minus 3, y is equal to 5. Now, suppose I set x equals 3. Y is equal to 4 times 3 minus 3. 4 times 3 is 12, minus 3, so y is equal to 9. Now look at what has happened here. When I increased x by 1, y increased by 4, from 5 to 9. So, why is that important? Because this 4, this increase by a value of 4, is predicted by the fact that this slope over here, this coefficient of x, is 4. So what does this 4 mean? It means that every time x goes up by 1, y must go up by 4. And the same thing holds true in reverse. Supposing I tried x equals 1 and I solved for y. Y equals 4 times 1 minus 3, which is equal to 4 minus 3, which is equal to 1. So when x went down by 1, y went down by 4. Again, that is controlled by this coefficient of x. So the coefficient of x will tell you how much y is going to change by if x increases by 1 or if x decreases by 1.
There's another class of equations we will see called quadratic equations. Unlike linear equations, where we didn't see an exponent, here one of the x terms is squared. It has an exponent of 2. All quadratic equations have an x squared in them, but they can never have an x raised to the third power or anything else higher than 2. All quadratic equations follow the same basic pattern. There is always an x squared, and it may be multiplied by a coefficient. We symbolize that coefficient as a. There is usually an x term, and it too might be multiplied by a coefficient. We'll call that b. And finally, there is usually another number added. We usually call that c. So the basic pattern of any quadratic equation is y equals ax squared plus bx plus c. If we were to plot these equations on the Cartesian plane, we would get these shapes. They're called parabolas. Parabolas and the quadratic equations that form them are supremely important in physics. In fact, they are the backbone of kinematics. You'll notice that parabolas are symmetric shapes. Most of the ones we see here cross the x-axis twice. Those locations where it crosses the x-axis are known as the zeros of the parabola. It's pretty common to need to find the zeros, and we have this equation to help us. It's called the quadratic formula.
Here is a typical quadratic equation. 2x squared plus 3x minus 14 equals 0. We can solve it using the quadratic formula. That is, we can find the values of x that make this equation true. There will be 2 of them. To solve this, we need to find the values of a, b, and c to plug in. That's easy enough. We use the coefficients in the quadratic equation. A is always the coefficient of the x squared term. That's 2. B is the coefficient of the x term. That's 3. And c is the constant term. That's negative 14. Now, let's plug everything into the quadratic formula. X equals negative, b is 3, plus or minus square root of b squared minus 4a to c, negative 14, all divided by 2 times a, which is 2. Let's start simplifying this. This is just a negative 3 plus or minus. Now, 3 squared is 9 minus 4 times 2 times negative 14 is negative 112. All of this is divided by 4. Let's keep simplifying this. Nine minus negative 112 gives us 121. And the square root of 121 is 11. So now we can break this into the 2 solutions. The positive solution and the negative solution. So negative 3 plus 11, that gives us 8. And negative 3 minus 11, that gives us negative 14. So either x equals 2 or x equals negative 3.5. So these are our 2 possible solutions to this quadratic equation. We can also use the quadratic formula to solve slightly more complicated quadratic equations like this one, x squared plus 4x minus 2 equals 0. What makes this one slightly more complicated? Well, let's take a look. First, let us say what a, b, and c are. A is the coefficient of x squared, that's 1. B is the coefficient of x, that's 4. And c is equal to -2. Plug all this information in. X equals negative b, that's -4, plus or minus square root of b squared minus 4ac, all divided by 2 times a. Now let's simplify this. X equals -4 plus or minus square root of 4 squared is 16 minus 4 times 1 times -2 gives us -8. All divided by 2 times 1 is 2. Simplifying the term under the radical, we get x equals -4 plus or minus the square root of 24, all divided by 2. But 24 is not a perfect square. Don't you just hate it when that happens? Nevertheless, we can still solve this, or at least approximate it. The square root of 24 is about 4.9. So we can say that x equals -4 plus or minus 4.9, all divided by 2. And if you want to be a little bit more accurate, let's say x is roughly equal to -4 plus or minus 4.9 divided by 2. Now, let us split this into the two possibilities. The positive side, x is roughly equal to -4 plus 4.9 divided by 2. And the negative side, x is roughly equal to -4 minus 4.9, all divided by 2. So, x is roughly equal to 0.9 divided by 2, which means x is roughly equal to 0.45. Or x is roughly equal to -8.9 divided by 2. So x is roughly equal to -4.95. So these are our two solutions. Sometimes a humble-looking quadratic equation like this one, -x squared minus 2x minus 5 equals 0, can have a dark secret lurking inside it. Let's try solving this using the quadratic formula. A, the coefficient of x squared is -1, the coefficient of x is -2, and the constant term is -5. Let us plug all this information into the quadratic formula. X equals negative, b is -2, plus or minus square root of b -2 squared minus 4 times -1 times -5, all divided by 2 times a, -1. And now let's start simplifying just as we did before. X equals -2 becomes +2, plus or minus the square root of -2 squared becomes 4, minus 4 times -1 times -15 gives us 20. All divided by 2 times -1 is -2. Simplifying still further, we get x is equal to 2 plus or minus square root of -16 over -2. The square root of a negative number. Now, From your math classes, you might remember that it is actually possible to do this. Taking the square root of a negative number produces something called an imaginary number. Imaginary numbers are an intriguing and wondrous concept with many practical applications. For the most part, we can solve this quadratic equation by using the imaginary number I over here. So, once again, the plus side now becomes 2 plus 4i, all divided by negative 2, and the negative side becomes 2 minus 4i, divided by negative 2. So x is equal to 2 divided by negative 2 is negative 1, 4 divided by negative 2 is minus 2i. Or x equals 2 divided by negative 2 is negative 1, negative 4i divided by negative 2 is going to give us plus 2i. This corresponds to the zeros of a parabola that does not cross the x-axis. Now, while there are many theoretical and practical applications to imaginary numbers and the complex numbers that occur when you add imaginary and real numbers together, we are not going to be requiring them for this level of physics. In these cases, we will just say there are no real solutions.
In this video, we have summarized the techniques of algebra that you will need for this course. In the next video, we will introduce some of the basic trigonometry you will need.